All right, so this is going to be, let's start where we left off. How many points do you need to make a straight line? Two. Excellent. So let's do a graph. Okay, this is going to be what? This is going to be, what does it say on the video? Look at the graph. What's on the x-axis? Celsius is on the x-axis. Okay? So this is going to be degrees Celsius, and this will be degrees Fahrenheit. So it'll be, how do you spell Fahrenheit?
F-A-H-R-E-N-H-E-I-T.
R-E. Maybe if one person spelled it to a deaf person, I could understand it. So one person. Victoria?
N? No, from N.
N?
Okay. F-A-H-R-E-N-H-E-I-T.
Okay, Fahrenheit, yes? You get how to spell it? A little weird, okay? Not bad. How do you spell Celsius?
C-E-L-S-I-U-S.
Right? Celsius? Yes? So I'm going to have an ordered pair. I need two points, right? What identifies a point on this kind of graph? An ordered pair, correct? Yes? X and Y. We went over X and Y. All right, so I need a pair A and a pair B. And I need degree Celsius, degree Fahrenheit. Okay? Yes? Yes? What's a point for degree Celsius which relates to Fahrenheit? So for instance, we'll say this. We'll say Fahrenheit, we'll say Celsius, we'll say melting point, we'll say boiling point. Okay? Does anybody know what the melting point is of anything though? You need 2 melting points and 2 boiling points. Does anybody know? Yes, Linda.
32 for Fahrenheit.
Wow, very good. 32 for, yeah, good. 32, where are you from, Canada?
Yeah.
Do you use Fahrenheit up in Canada?
No.
No, but you know that.
Yeah.
I like that. Okay. 32, right? And then, what else?
Celsius 0.
Celsius is 0. Well, very good, Linda. What else? What else do you know? Let's see if you can finish the whole thing. Do a hat trick. What is it?
212 for Fahrenheit.
212. I'm impressed. And what's left? Go ahead, Linda. Finish it up. 100. Good. All right. So you see, what are our 2 points going to be then? What are our 2 points going to be? Are they going to be this and this, or this and this, or this and this? What's it going to be? What's it going to be? Kennedy.
Yes, it will be 032.
0, 0, 32. Excellent. And B will therefore be 100, 212. Good. So, in other words, they have to relate, don't they? Yes? Because aren't we relating Celsius and Fahrenheit?
Yeah.
Yes. So don't they have to relate somehow? So isn't the relationship going to be melting, freezing, boiling, condensate? Yeah? So graph these 2 points. So graph A. Wouldn't it be like right here? This is 0. So it's going to be 0, 32. So this is A. 0, 32. Right? Yes? Yes?
Yeah.
Now do what? Do the next one. What do you got? Can we make this, we're going to make this taller. Okay. Can you see that on the, can you see that? The whole thing? Yes? Cool. Okay. So this is going to be, what's the next point you got to do? What are the coordinates?
100.
What is it?
100 and 212.
100. So we'll say that this is 100. Yes? And then this is going to be, we'll say this is 212. It's not perfect. Okay? Don't even go there. It's not perfect. Yes? Are you okay with this?
Yeah.
Okay. So this is going to be 212. Okay? All right? Yes or no? Cool?
Yeah.
And we'll say that this is B, and we'll say that that's going to be 100, 212. Okay? Now, just so we get this out of the way, we'll say what? We'll say, what are we going to say? We'll put this up here. We'll say A is going to be 0, 32. Right? Is that out of the way? Close enough. Okay? Yes? So now you've got to draw your line. Okay? I just know I'm going to do a rotten job with this, but we're going to try it. Okay? Let's do red. You ready? Okay. Pretty terrible, but that's okay. So this is my function, correct? Yes? Function, yeah, yeah. Function. Okay. Let's, because this is on film, we can do this. So, now that's a straight line. It looks a little curved, but that's just an optical illusion. Okay? So, I want to write the equation. I want to write the equation in this form. Y equals mx plus b. What can I put in? Do I know anything right now? What's y?
Which point?
What's y? No, I don't need to know a point. What's y?
Fair enough.
I don't know m yet, do I?
No.
But do I know what x is?
Yeah.
What is x?
Celsius.
So we'll leave the m there. And then what's b? Do I know what b is yet?
No.
32. B is the y-intercept, right? Isn't it intercepting the y-axis at 32? So, what do we have to do? We have to do what? Yeah, I like that. Rise over run. So we've got to do this. Okay, what's the rise? It goes from 32 to 212. What is that? What is it? 180. Okay, that's the rise. What's the run? It goes from what to what? It goes what? No, it goes from 0 to 100. What's that value?
100.
100. How do I do slope? M equals rise over run, which is the same thing as what? Change in y over change in x, correct? Is that coming up on the film? Can you be my videographer, Linda? What is a photographer?
Yeah, okay, but
You just make sure it's still running. You're in charge. Okay. So it's going to be 180 over 100, right? What's 180 divided by 100?
1.
What is it?
1.8.
What temperature scale do you think is going to be more precise? Just Give me a guess.
Fahrenheit.
Why?
Because it has a smaller
Degree.
degree.
Yeah, it has a smaller degree. How many, between freezing and boiling, how many graduations are there? 32? What's
180.
180, isn't there? Yes? How many graduations are there between freezing and boiling for Celsius?
100.
Yeah, it's almost 2 to 1. So yeah, it's going to be closer graduations mean essentially more accuracy, more precision, right? Yes? Yeah. But we don't use Fahrenheit, do we? We use Celsius. Clear? Okay. So that's the final equation. What we did was we did the equation for the relationship, the function, to convert Celsius to Fahrenheit. Mr. Baslin? What'd you say?
I just said to find Celsius.
Correct. No, well you could, how, if I wanted to put Fahrenheit in to find Celsius, what could I do? Just rewrite the equation, couldn't I? Right? Okay. So body temperature is what? What's body temperature?
Body temperature is
37 degrees Celsius, right? So anywhere along this line, so if I put 37 here, let's say that that's 37, I want to know this. So this equation allows me to do that. I can pick any known point here, plug it into the equation and get that. Any point on this line I can do that with. Clear? And if I wanted to rearrange the formula, you're on film, you don't want to come any closer. What's this? Oh, that's my new badge? I got a new badge. I'm excited, yeah. I got a new badge. I am new. Okay. I am new. I have a new badge. Excellent, thank you. Thank you very much. I feel very... What is it? Oh, you want the pen? She gives me a pen and then she takes it back. Thanks. I got a new badge. Wow, huh? This is the horizontal version. Okay. What do you think? What's better? Same picture. Newer.
The old one's better.
This one has some food on it. I'm kidding. All right, so now that's it. So calculate, plug in, take out your calculators. Say 37 times 1.8 plus 32.
98.6.
98.6, and that's actually correct. If you go to the United States and you go to the store and you buy an old-fashioned glass thermometer with mercury in, and there's an arrow right over the scale, 98.6. It's like a little scale, a little part of a scale, and it goes from like 90 to 100, you know? Or not even. I think it's like just this part. Just this part is there. Right? And 98.6 would be like right here. And they have a little arrow. Must have been a chemist designing that. Doesn't it look like my class, right? Little arrow over it, tells you what it is. So if the mercury is past that little arrow, it means you got a fever, whatever. Okay, so that's our part 2 of Fahrenheit versus Celsius. Clear? We're off.